This is Dr. Frederick. Question about one of the homework problems. And what I want you to do is, if you ask a question, put in the module number, module 1. This is question 4. So just put down module 1, question 4. And if you work some of the data, put in your Excel file, put it in an Excel file, and attach it to your question. And the data are ready to evaluate. Now I'm just going to show you what you can do with these problems. Here's a question: is a sample of 25 people is selected, and the length of time to prepare and cook dinner in minutes is recorded, with the results shown in the accompanying table. And here's the table. We click that and we get that. Click the icon to view the table. Now I thought they had fixed this so it was easier to copy those data out, but apparently not. Now, what are we going to do is we're going to ask a question: is the population mean 45 minutes or not? And so the question is there evidence that the population mean is different than that? So we're going to use hypothesis testing. The p-value approach is simply to say we're going to find, we're going to use a certain level of significance to evaluate the null hypotheses. And if our results are outside of 10%, higher than 10%, in other words, if there's greater than a 10% likelihood that we would see the results given our data, then we're not going to reject the null hypothesis. But if there's a probability of less than 10%, we're going to reject our null hypothesis. So, look, when you're in these problems, you come over here and try this one. Help me solve this, and it will tell you what to do. So here's the same thing, different data, not the same data. But here's how I solved this problem. First thing I did is I went to StatCrunch. So you click StatCrunch, open up StatCrunch, and let me find out where it is. I already entered all the data here. If you go to StatCrunch, it says, look, work on the dinner problem. If you go on the dinner problem, then we see times 44, 51.9, so forth. Let me find out where we were. I'm going to close this. Here's our data here. Not the same data that's in StatCrunch. Okay, but what you can do is just type in the data that's in our example here, which is what I did. So we put those data in. I'm going to use those data. I have them right in StatCrunch. I could edit that name and probably I could just backspace and just type in the name of what you want it to do. So this is a sample. Somehow I've screwed it up now by not putting all the data in. Let me go back and look. All the data are changed now. Okay. Excuse me. I'd already worked this problem out. And typed in the data. I'm just going to type them in here into an Excel file. There were the old results that I'd already gotten for this, but let me just show you how I do it. Let's get a new sheet here. Okay, so I'm going to type in 43.7, 33.1, 27.3, 54.4, 36.9, 18.6, 37.7, 41.8, 58.8, 51.7, 37.3, 40.5, 20.5, 39.7, 49.2, 54.6, 32.1, 38.2, 27.7, 54.7, 57.7, 54.8, 48.5, 54.2, 46.1. Now, what we want to do here is grab these, copy. I'm going to go ahead and put this great. Now, okay, let's go back to StatCrunch. There we go. And now we'll just paste. Okay, we should have 25 values in there. We do. And to use StatCrunch, just hit Stat, do Summary Stats, we'll do Columns. I want to get the sample data, hit Calculate, and there are my sample data. Now, options here, just copy, and then I'm going to bring this back down. Just click in a cell here and click Paste, and there's the data from this sample problem. Now, I'm just going to stick this off the page where I can see it. I'm going to close this. I'm going to close this and go back to this question. We'll continue through the practice. Continue. To perform the hypothesis test, first identify the null hypothesis. Well, the null hypothesis is that the population mean is equal to 45, and the alternate hypothesis is that it's not. That's what's going to be called a two-tailed hypothesis, which means that if our sample mean is significantly greater than 45, we're going to reject the null hypothesis. And if our sample mean is significantly lower than 45, we're going to reject the null hypothesis. And we're going to do that using a t-test. And the critical t-value will help us decide what to do at the chosen alpha or risk level that we have, and we'll see what that's going to be. Here it wants us to have an alpha equal to 0.01. This is the sample problem. So we have to figure out what alpha over 2 is, and that's going to be 0.01 divided by 2, which is 0.005. Okay, check the answer. Good boy. Keep going. Now find the degrees of freedom, 24. Check the answer. Good job. And now it says, okay, you should have all your data to figure this out. You find the t observed, or the t statistic, and that's the sample mean minus the population mean. What's the population mean? 45. What's the standard deviation? Well, it's whatever we just found in StatCrunch, and our n is 25. Continue. It says, first of all, tell us what the mean is. Well, we saw it here in StatCrunch. The mean is 42.392. Okay, 42.392. It wanted 4 decimals. Let's see if it'll accept that. Okay, it does. And then find the sample standard deviation. Okay, I'm just going to copy it out of my output and paste it in here. Okay, it says round to 4, so that's going to be 5.7 5.49. Check the answer. Fantastic. Now find the value of mu. We know it's 45 is our hypothesized value of the population. That's good. And now figure out what this is, 42. Now I'm just going to show you how. You can do this on a calculator, or you can just pop Excel in here. Okay. Here we have 42. I'm going to say, let's figure out what this is equal to. 42.392 minus 45 divided by 11.5749 divided by 5, the square root of 25, and that's equal to this value. Copy. Paste. To 4 values, 1.166. Right? So let's check that answer. That's good. Okay. Now what's the p-value? Now what we're going to do now is we're going to use what's called a t-calculator. You can use a chart in your table, in your books if you want. I always anymore just go to the internet. I just Googled t-calculator and I looked for one that had a two-tailed p-value. It's simply going to tell us what percentage of this t distribution is beyond our critical value in both directions. And here's what that means. Let's find our t-value. Our t-value is negative 1.1266. Of course, I've already forgotten it. Let's just see if it's still there. Okay, I just pasted it in. It is negative. We are doing two-tailed. We'll calculate that, and it's 0.2711. Let's copy that. We'll go back here to our problem and see if that's right. It is. What it's saying is, outside of the t distribution, how much area is in the curve from negative 1.13 to positive 1.13? Well, 27% of the curve is out there. Okay, and so we're using the p-value method here. And if the p-value is less than the level of significance, reject the null hypothesis. Otherwise, do not reject the null hypothesis. So our alpha level was 0.01 here. Our p-value was 0.01. That's our critical value that we're going to compare to. Our value is much higher than that, so we do not reject the null hypothesis. And that's our conclusion. Now, it's going to ask us what assumptions were needed, first of all. Let's review the assumptions. Okay. Well, we do not assume that the population distribution is skewed, and we do not assume that every value is the same. We say that the values are distributed normally. Okay. We'll continue here. And what was the question? The question is, make a list of all the various ways you could evaluate that assumption of normality. Okay, there are several ways to evaluate the normality. Check all of them. Well, we could make a histogram and see if it looks bell-shaped. We can make a normal probability plot and see if it's linear. We could get a box plot and see if it looks symmetrical. We could determine if approximately 2/3 of the data lie within one standard deviation of the mean. Because in a normal distribution, that's 68%. Okay, all of those are true. We continue. While a normal probability plot, box plot, or histogram can be used to determine if the population distribution is normally distributed, use a normal probability plot. So, okay, well that's kind of linear. That's flat. We're not interested in that. This is not linear. It's a stepwise progression. I'm going to pick A here and see if that's right. Yes, I'm fantastic. Okay, that's how you do that problem, and every problem comes with help me solve this. It allows you to work the problem by looking. So I hope that's a helpful answer to the question. Keep your questions up, but help me out to answer them right away. Module number, problem number, provide the data set.